In today's lesson, we are going to be looking at concentration in chemistry. What is concentration? Okay, I believe that by the end of today's video lesson, you will be able to solve questions involving concentration and acid-base reaction. Now, concentration is the amount of solute in grams or moles. Please take note of that. The amount of solute in grams or moles that is dissolved in 1000 cm³ or 1 dm³ of the words of the solvent. Now, so concentration is either measured in grams, or it is measured in moles. Take note of this important term. So concentration is the amount of solute that is measured in what? In grams, okay, or measured in moles, that is found in 1000 cm³, which is this, or 1 dm³. You must note that 1000 cm³ is the same as 1 dm³. And whenever you see dm³, is the same as 1 liters. It must be noted. So there is no difference between your dm³ and your words, your liter. Now, of the words solvent. So it's either we measure the solute in grams or we measure the solute in words, in moles. Now, if you look at the breakdown of concentration, you will see that there are two basic types of concentration. Yes. The first one is called mass concentration, okay? While the other one is called molar concentration. What is the difference between them? Now, your mass concentration is the amount of solute in grams. Don't forget that there was gram in the definition. Yes, the amount of solute in grams that is in 1 dm³ of the solvent, okay? Or, so therefore, we have that this symbol is the mass concentration, okay? The mass concentration is also referred to as the density of the solution. Good. So take note of this. It must be noted. While your molar concentration is the amount of solute in words, in moles. Yes, in moles. Remember, it can either be in grams, which is mass concentration, or it can be in moles, which is molar concentration. So this one is based on grams, which is mass. Then this one is based on what? In moles, which is called molar concentration. Now, your mass concentration is termed as what? Density. Take note of that. It must be noted. Then your molar concentration is termed as what? Molarity. So, understand the fact that solute is either measured in grams or it's measured in what? In moles. Both of them are referred to as what? Amount. Now, there should be a similarity or a formula that relates what? Your mass concentration with your molar concentration. What is the formula? Take note of this. It must be noted that molar concentration, remember I told you that molar concentration is called weighting molarity. Molar concentration is equals to mass concentration over the molar mass. Take note of this. It must be noted. It must be noted. So, molar concentration, which is also called molarity, is equals to your mass concentration over the molar mass. That means we can convert from molar concentration to mass concentration and vice versa, okay? Now, here is another important fact about these two types of concentration. Your mass concentration is measured in grams per dm³, because it talks about the amount of solute in grams in 1000 cm³ or 1 dm³. Then your molar concentration is measured in mole per dm³. It must be noted. Okay, so because it talks about the amount of solute in moles that is in 1000 cm³ or 1 dm³. So take note of this. This is gram per dm³. This is mole per dm³. So we will say that that molar concentration, which is given to us in mole per dm cube, is equals to concentration, mass concentration, which is given to us in gram per dm cube over weight in a molar mass. Your molar mass is gram per mole. Wow, that's interesting. So let's bring out the formula. We have C, which stands for molarity, in mole per dm cube, equals to rho. This is a symbol for mass concentration, it's also called density. And this guy is in gram per what? Dm cube over your molar mass, which is what? Gram per mole. So this must be noted. By the time these units are combined together, you'll see that it returns back to mole per dm cube. Now let's continue to the next phase of, don't skip this video, stay with me to the end of this channel. Now class, we are in the next phase, which is called dissolution of solution. What do I mean by this statement? Now, if the molarity, which is also known as concentration of a solution, is already known, we can further dilute that solution by adding some amount of water to the solution. So in that case, it is referred to as either dilution of solution or dissolution of solution. When water is added to a solution of known concentration, the concentration of that solution tends to what? Reduce. But when water is taken away by evaporation or by any other means from a solution of known concentration, then it is known as concentrating the solution. So in that regard, we will discover that what? That C1 V1 is equals to C2 V2. This is the formula that is used to solve problems involving dissolution of a solution or dilution of that solution. Now, what does C1 means? It must be noted that C1 is equals to what? Initial concentration. Initial concentration, don't forget I told you, in what? In mole per what? Dm cube. Yes, this is the initial concentration in mole per dm cube. What does C2 represent? It represents final concentration in the same mole per what? Dm cube. Don't forget. Then what does your V1 represent? It represents initial what? Volume. Okay, in what? In cm cube. Then your V2 signifies what? Final volume in what? In cm cube. So take note of this. It is either both volume are in dm cube or they'll either be in what? In cm cube. But you must note that the initial and the final volume must be of the same unit. Please take note of that. It is very, very what? Important. More also, it is important that we talk about our dilution factor. Sometimes as a student preparing for WAEC, or you are preparing for your JAM, or you are preparing for post-UTME exam, there are certain questions that look strange as it has to do with this topic. And one of those questions is called dilution factor. Sometimes you might be told to determine the dilution factor of a solution. Okay? If you come across such question, how will you solve it? This is the formula to demystify. Dilution factor is equals to C1 over C2 or V2 over V1. That is to say, your dilution factor is the ratio of the initial concentration to the final concentration, or the ratio of the what? Final volume to the initial what? Volume. So you must understand the fact that because dilution factor is the ratio of two quantities of the same unit, it means that it becomes what? Unitless. It must be what? It must be noted. Now I think we should solve like just 3 questions on this before we continue. It's likely examination questions. The question says, what volume of a 11.0 m? Please, I want you to note this. Whenever you see capital letter M in chemistry, it signifies what? molarity. And don't forget that molarity is concentration in mole per dm cube. So because of that, we can say that they say what volume of A, this is the initial concentration. So it means that we are looking for the volume of this concentration. Is that clear? Good. So you have V1, let it be equals to what now? X. So what is the initial concentration? C1 equals to what? 11.0 mole per dm cube. I've told you before, capital letter M signifies concentration in mole per dm cube. Okay, hydrochloric acid must be diluted to obtain 1 dm cube. So this is the final volume. That's 1 dm cube. So what is now our C2? They gave us a concentration 0.05 mole per dm cube. So it's very easy. Remember I told you that dilution of a solution has a formula C1V1 is equals to C2V2. From the look of things, we are looking for what? V1. So if you make V1 to the formula, you have V1 equals C2V2 over C1. So let us put our variables. We have C2 to the 0.05. We have V2. What is V2? We have 1. Then we have C1, which is weighting at 11. So you have 0.05 over 11. Let's do that quickly. So we have 0.0045. We have 0.0045. Okay? So what do we quickly do? It means that we have 0.005 what? dm cube. Don't forget, we are looking for what? Volume. 0.05. So what's the answer to this question? If we approximate this, we have 0.01. So it is not this. Let's take it from here. This is not the answer. This is not the answer. This is not the answer. So we'll probably have 0.005 what? dm cube. That's the answer. Wait for the next question. Now let us take this second question. This is a little bit more difficult than the first question, okay? Now the question says, if 1 liter of 2.2 molarity sulfuric acid, remember that sulfuric acid is the industrial name for tetraoxosulfate, what? 6-acid, is poured into a bucket containing 10 liters of water. Don't forget, if you take an acid of this concentration and you add it into water, the acid becomes what? Diluted, and the volume of that solution will change, okay? So because of that, they said the resulting solution is mixed tolerant. The resulting sulfuric acid concentration will be what? We are looking for the concentration of the acid. First of all, 1 liter V1 is equals to 1 liters. Don't forget that. And the first concentration C1 is 2.2 molarity. Don't forget I told you molarity is mole per dm cube, okay? Now when they took it and poured it into 10 liters of water, what do you expect? The volume of the water, which is V2, will change. V2 will become the 10 that it was plus the 1 liter that was added to it. So you must be very careful. We have plus 1, and that will give us 11 weighting at 11 liter. So we are now looking for what? C2. Remember, our formula remains the same. We have C1 V1 is C2 what? V2. What is our C1? Cyan 2.2. What is our V1? Cyan 1 equals to C2. We do not know C2. But what is our V2? Our V2 is what? 11. Remember I got 11 by adding the initial volume of water plus the final volume of water, because the old one was added to the new one. So you have 22 is equals to what? 11 C2. So what do we have? Divide both sides by what? By 11. So when that happens, we have, sorry, this is 2.2. So 2.2 times 1, 2.2 is equals to C2 times 11 C2. So we divide both sides this way. So you have C2 is 2.2 over 11. Let's do that quickly. So 2.2 divided by 11 will give us 0.2 mole per what? dm cube. So let's check the option quickly. 2.2, no. 1.1, no. 0.11, no. 0.20, the same with 0.2. Thank you very much. That is the answer. I have one more question before we call it a day. The last question for today's video lesson. We have a molar solution of caustic soda is prepared by dissolving water. Okay, caustic soda has a formula which is sodium hydroxide. This is your caustic soda, while potassium hydroxide is your caustic potash. Now, how do we prepare a standard solution of caustic soda? Don't forget, they said a molar solution of caustic soda is prepared by dissolving water. Now, how do we prepare it? Remember that if you solve the molar mass of this guy, you have 23 plus 16 plus 1. That will give us 40 grams per mole. So the molar mass of caustic soda is 40 grams per mole. So a molar solution of caustic soda is prepared by dissolving 1 mole, which is the molar mass of the caustic soda, in 1000 cm cube or 1 dm cube of the word solvent. Okay, now don't forget that if the solvent has to do with water, the mass of water is the same as the volume of water. So if I say 1000 cm cube of water, it's the same thing like saying 1000 grams of water. The reason is because the density of water is 1 gram per cm cube. So if the mass is given to us in gram, don't forget, density is mass over volume. So if you cross multiply, you see that the mass of water is the same as the volume of water. So we prepare caustic soda solution by dissolving 1 mole of caustic soda, which is the molar mass, 40 grams, in 1000 cm cube or 1000 grams. So what do we say? The answer is not A because we have 100. The answer is what? B, because we have 40 grams of sodium hydroxide in 1000 grams. Okay, it's not 20, it's not 20. So the answer is what? B. Now, look at this question. You have to solve these two problems. They are exam questions, they are likely exam questions. Send your answers to me in the comment section. But don't forget to subscribe to this YouTube channel for more content. We are going to see in the next part of concentration problem. Have a nice day.